Hi everybody, welcome to the demo, the show where companies come in and they show us their products and platforms. Today I'm joined by Kurt Medell. He is a Senior Solutions Architect at Loft Labs. Welcome to the show, Kurt.
Thanks for having me.
All right, so tell us a little bit about Loft Labs and then what you're going to be showing us here on the show today.
Sure. So Loft Labs is a Series A startup that's dedicated on simplifying Kubernetes.
Okay.
So basically, we believe that we're going to drive the next level of technology by building a virtual Kubernetes and making it standard for building and operating cloud-native platforms and applications.
Okay, and you've got stuff on your shirt that says vCluster, so that's, I'm assuming that's the name of the product.
So vCluster is kind of our flagship product and the one I'll be demoing today. But basically, we believe that virtualizing the cloud-native stack is going to impact the cloud era the way that virtualizing physical servers did over 30 years ago.
Oh wow, okay, so and so who is this designed for within the company? Is this a CIO level thing where they're observing everything, or is this really just the developers that are working with Kubernetes and the clusters and all that other kind of stuff?
Well, all the above really, but our main kind of target from a sales perspective, I'm on the sales team, is platform engineering teams.
Okay, all right.
That are actually building these solutions with Kubernetes for developers, multi-tenancy, et cetera.
All right, so take us through like the problems that companies are currently having, and then how vCluster can help them solve that problem. Basically, it's like, why should anybody be watching this video?
Sure, of course. So basically, I mean, the use of Kubernetes is exploding across companies around the world. And it's getting more and more expensive for them to manage Kubernetes at this scale.
Okay.
So basically, the vCluster and vCluster platform allows platform engineering teams to not only more easily manage Kubernetes at scale, but also reduce costs while they do it.
Right.
So as you know, the use of Kubernetes continues to grow, and more companies are using Kubernetes, vCluster allows you to create isolated multi-tenant clusters on a host cluster with things like sleep mode and the ability to share the platform stack of the underlying host cluster to reduce costs.
Does this problem get bigger and bigger the more that you're deploying? Like the larger you get with your deployments, the larger this problem? Is it a straight line? Is it exponential? Like when do companies start noticing that they might have a problem?
It's interesting. So in some cases, they notice early on, even with a smaller Kubernetes kind of deployment, because they can't give a developer a Kubernetes environment that they need to get their job done. The developer doesn't have the isolation or the ability to deploy the resources they need to deploy by sharing a cluster. So vCluster allows you to have a dedicated cluster for one individual or one team. It's not limited to say, hey, this team has to share this cluster and this team has to share this cluster. So even with a smaller organization, but certainly the cost savings grow and exponentially as your Kubernetes footprint grows.
And so if a company didn't have this, what would they be doing? Would they just be spending a lot of time going back and forth and doing all of this deployment and taking a long time, or would they just be spending a lot more money than they probably need to?
Well, a little bit of both. Great question, by the way. But basically, there's kind of two main approaches for the companies that aren't using vCluster. One is just to spin up additional physical clusters, and that gets harder to manage. It's more expensive to manage, and it costs more. Regardless if you're on-prem on bare metal or in the cloud, like AWS. More clusters cost more money. Or they use namespaces. Namespaces is kind of a very limited multi-tenancy in Kubernetes, where you can carve up one Kubernetes cluster into several namespaces, but developers don't have the autonomy or the freedom to do what they need to do to get their job done.
Right. All right, so let's jump into the demo and show me some cool features here.
Sure. So today I'm going to basically take a look at vCluster and vCluster platform.
Okay.
And we're going to start by taking a look at a very common use case for platform engineer teams, where they need to have a dedicated Kubernetes cluster for every GitHub pull request. Basically, a pull request, when a developer makes a change to an application, there's a review process, and GitHub has this pull request for that. So what the vCluster and vCluster platform allow you to do is create a workflow. In this case, I used Argo CD cross-plane with vCluster platform and vCluster. And so every time somebody creates a pull request, all a developer has to do is add the simple label here, create a PR vCluster.
Okay.
It could be whatever you want. And that's going to kick off this workflow that is going to create a vCluster that deploys this application change into that vCluster. With the benefit of sleep mode that I mentioned before, basically with sleep mode and auto delete, even if this pull request is around for days or weeks, the vCluster is not running that whole time. Because if they're not actively interacting with that vCluster, then the platform actually puts that vCluster to sleep, meaning it spins down all the resources that are actually costing you money down to zero.
Okay.
And then if they need to look at it, they click on a link, they interact with the API server of that underlying vCluster, and boom, the platform wakes it back up. And because the vCluster is very lightweight, it runs just as a pod in a namespace, it spins up very quickly like a container.
Okay. Yeah, so basically with the sleep mode then, if you're, let me see if I get this right. So company without that would be just building these deployments, these clusters, and then they'd just be sitting there and you're charging. It's like you're leaving the lights on at the house when
or they don't do it.
Yeah,
it can be just as bad. So
yeah.
they don't provide a dedicated cluster for a pull request.
Right.
And then there's a bug that surfaces later, in the process that costs them more money.
Okay.
So it's either they do it and it's slow and expensive. Not that only does it cost more, but to spin up an EKS cluster takes 20 to 30 minutes at a minimum.
Okay.
Whereas a vCluster spins up in seconds.
Right.
So that developer's not sitting there waiting for their environment. So yeah, there's multi-facets to it.
All right.
But yeah, so for example, here is that vCluster for that pull request. We want to take a look at the application. This is just a really silly demo application.
Yep.
But basically, if they just click on this link, that takes them to the application where, if I increase the size here, that is the actual commit from the pull request right here that was deployed into that vCluster. Now, if we look at this vCluster, you'll see I actually deployed Argo CD along with the actual application into the vCluster itself. So they have a dedicated ephemeral Argo CD instance and an ephemeral Kubernetes cluster. But now, so you see all these pods are running. If I go to the namespace where this is running, you see a bunch of pods. They're costing money. They're using memory CPU of the underlying host cluster. So just for demonstration purposes, I'll go and I'll actually put this guy to sleep, which can happen automatically. This is configured to go to sleep after 2 hours of inactivity.
Okay.
So now this vCluster is going to go to sleep. Now if I go and look at that same namespace on the host cluster where this vCluster was running, you'll see 0 pods running.
Oh, okay. Cool.
And now just as quickly I could wake that up and everything just comes back to, awake and is available.
Yep. Okay.
So now I was going to take a look at what a developer's, life could be with vCluster platform and vCluster.
All right.
Some of the different ways that they might interact. Like if the platform team hasn't set up some kind of automation for a pull request like I just showed, a developer comes in, they just need a one-off vCluster to do some work. Okay, so I'm actually going to start by impersonating a user, which is another feature of the platform. So I'm going to impersonate Anna.
Okay.
And so one thing you'll see is that the UI is going to change because she has less permissions within the platform. For one, if I go and click on a vCluster that she has access to, like this API framework one, and go to the local cluster, you'll see she doesn't have access.
Okay.
There's no need to give access to your developers to the underlying host cluster.
Right. Or you give everything to everybody, right?
Right, exactly.
You can limit what they see and what they do.
And so within this project, another kind of nice thing is Anna can only create a vCluster with a template. So she doesn't have to know all the inner workings of vCluster to create a vCluster and use it just like any other Kubernetes cluster.
Okay.
She'll use a template. And this, I'm going to also do another demonstration of sleep mode here and use this Sleepy vCluster template and name it Sleepy. So it allows them actually to set the inactivity period for sleep mode. Also, they can select different versions of Kubernetes to run in the vCluster. You don't have to use the same version of Kubernetes in a vCluster as is running on the host, which is another powerful way for testing and making sure your application runs on a newer version or older version of Kubernetes.
Okay.
So we'll go ahead and create that. Create that vCluster. So another way, as that vCluster is coming up, we're going to go over here to this IDE, this VS Code IDE. And first of all, we're going to check to make sure that we're logged in as Anna. I think we're already logged in. So here we're logged in as Anna. And I'm going to use the vCluster command line interface, or CLI, to create a vCluster. So here we have a command that's going to use the platform to create a vCluster named Anna's Dev with a specific template version and setting a parameter for that Kubernetes version. So go ahead and enter that. One of the things, if you have access to multiple projects in the platform, our CLI is completely integrated with the vCluster platform. So we get a list of the projects that Anna has access to. So she's going to go ahead and select the API Framework project and hit enter. So now if we go back over to our platform, we'll see that we have 2 vClusters coming up. We have Anna's Dev and Sleepy.
Sleepy.
And Sleepy is not yet ready.
It's almost.
So this is
there. Oh, is it asleep? It's asleep now. Oh no, not yet.
This is a little slower than usual. So Sleepy's
See,
finally up and running.
You were talking too fast. You had a 2-minute thing ready.
Exactly.
Okay.
So Anna can also use the platform. Depending on, you have some people that love to be in the terminal, love to use command line interface, that sort of thing. Other people like a user interface. So she can go in the user interface, interact with pods, look at the, so I can go and look at the deployments. Not sure what's going on with this pod, but you can look at the logs to see if there's issues with that pod. But now we can also go over here and wait. Okay, so now her vCluster that she created with the command line is up and running.
Okay.
So one common use case for a vCluster is deploying certain cluster resources that you can't deploy into a namespace.
Right.
So one example of that is Crossplane. We have Crossplane running in the host cluster where Anna created this vCluster. So she can't, install Crossplane in a namespace, but she needs a newer version of Crossplane to test some of the work she's doing on some Crossplane compositions. Well, first of all, we can do kubectl get namespaces, for example, and now she only sees the namespaces that are in her vCluster.
Okay.
Right? By creating the vCluster with the command line interface, she's automatically put into the kube context of that. Now we're actually on Crossplane 1.16 in our host cluster, but we're going to install a release candidate of 1.18 into Anna's vCluster. There we go. So now if we go back over to our visual interface, first of all, we see Sleepy is asleep.
Okay, yep.
That was obviously not a typical duration of time there, but
Sure.
just for demo purposes. And if we go and look at Anna's vCluster where she installed Crossplane, we can see the Crossplane pods. Also, one of the things we did with a virtual cluster template, which is another way where a platform team can more easily manage vCluster at scale, they can create these templates. And this template actually installed what we call the Helm dashboard. It's an open source application. We basically have templates where you can install Helm charts, just arbitrary Kubernetes manifest. And so we installed that Helm dashboard. So if Anna prefers, she can go and interact with, she just deployed this Crossplane via Helm. So now she can see it in this dashboard. Now, if Anna's done, she can go and delete the vCluster. Also, we have a platform feature called auto delete that will automatically delete the vCluster after a specified amount of time as well. So even if Anna didn't delete it, you don't have to worry about a developer forgetting about their vCluster, not cleaning up after themselves, which is pretty typical of a developer, right? But Anna is a good developer, and she's going to delete her vCluster because she's done with her testing. And now if we go back to our platform and stop impersonating, we'll see that Anna's vCluster is being deleted. In addition to that, you might notice these quota limits up top. So the quota limits basically are like namespace quotas in Kubernetes, but they're more powerful because they go across an entire vCluster platform project.
Right.
That means any vCluster, any cluster it's deployed to, you could have multiple host clusters that are part of a project, dozens of vCluster instances, and these quotas are across all of that.
Yeah.
Especially like when you come to something like GPUs that are so expensive, where you want to do your AI workloads and so forth.
Yeah.
And you definitely need quotas around those.
And Anna's thing is gone, and so is the Sleepy. Sleepy's gone too.
Exactly.
Yeah. All right. So all of this stuff that we just did in within the 6 to 7 minutes, how long would that have taken if people weren't using vCluster?
Well, to start with, like I said, it depends on if they're in the cloud or on-prem.
Yeah.
I mean, we've talked to companies on-prem where it takes a month to get a cluster.
Wow.
So obviously that's crazy. You're not going to make money in whatever you do to make money if you have to wait that long to get a cluster. In the cloud, it can be faster, and that's what the cloud tries to present to everybody. But you're still talking 20 to 30 minutes to create a cluster.
Yeah. And
it's way more expensive.
Yeah. Did you want to, now speaking of cost, did you want to show the dashboard for the
Definitely.
cost control? Okay.
So this is one of our...
What software without a dashboard?
Right. Besides the list of virtual clusters, that's nice as a single pane of glass for both the platform team to see what vClusters are running, that sort of thing. But the cost dashboard is one of our newer features, and basically it highlights the type of cost savings you can realize with vCluster.
Yeah.
One of those is sleep mode that we've kind of already taken a good look at. And just today already in this small demo environment, we've saved $27.
Right.
Now, if I go up here and look at like the last month, and give that a second, another part of the dashboard is by reducing the number of physical clusters.
Yeah.
Whether you're bare metal or cloud, but in cloud, that control plane's managed for you, sure, but you're paying for that. On average, a EKS control plane costs $900 a year.
Yeah.
So every time you reduce a physical cluster by using vCluster, you're saving that amount of money.
So now look at that.
So now, yeah, for over the last month, we've saved around $2,000.
Wow, that's cool.
So.
All right, so you've shown me a bunch of features, but I'm sure there's a lot more that people can discover. Where can they go for more information? And do you offer a free trial or
Yes.
a chance to test it out?
Yeah, we have a free 14-day trial. So just go to vcluster.com, and that'll point you in the right direction to our docs for vCluster. Also, we have a lot of other products. If you want to learn about some of our other products, you can go to loft.sh.
All right, Kurt Medell, thanks again for being on the show.
Thanks for having me. Appreciate it.
That's all the time we have for today's show. Be sure to like the video, subscribe to the channel, and add any thoughts you have below. Join us every week for new episodes of Demo. I'm Keith Shaw. Thanks for watching.